Alright, here we're going to talk about some similar triangle proofs. So we have these theorems, angle, side, and side similarity theorem. All of those would prove similarity. Really, that's the end point. That's where we're trying to eventually get to. And then we have some other theorems that might be helpful in proving that we have some angles or sides that are angles that are congruent or sides that are proportional. So let's get into our first one. It's pretty similar to the congruent triangles proofs, except for one pretty drastic difference when we have to set up proportions. I'll show you that on examples 3 and 4. So here we're shown that we have two parallel lines, AB and DE are parallel, and we want to show that these two triangles are similar to each other. So when you're given parallel lines, that means we can set up some angle relationships. I could say that angle E is congruent to angle A. That's our transversal cutting across our two parallel lines. That makes those alternate interior angles. And then I could use angle B and D, but I'm going to talk about these vertical angles here. I'm going to say angle BCA is congruent to DCE because they are vertical angles. And that's really all I need. I have two angles that are congruent, so I have angle, similarity. Similar setup here. I have parallel lines again. AB is parallel to DE. I notice that angle C is a part of this triangle, and it's a part of the bigger triangle. So angle C is congruent to itself by the reflexive property. And really the reason I'm saying that is because angle C is a part of both of these triangles. The next one, I could use two things here. I'm going to talk about these two angles. I'm going to say angle BAC is congruent to angle DEC because those are corresponding angles. I have parallel lines and a transversal that cuts across them. So if they're in the same spot, those are called corresponding angles, and we know that those are congruent because the lines are parallel. And since I have two angles that are in common between these two triangles, again, I have angle similarity. All right, all of that should be kind of familiar from congruent triangles, plus we've already talked about these similarity theorems. This is the real new part to this set of notes. All right, so we're told some side lengths here. We're told that AB is 12, AC is 10, DE is 3, DF is 2.5, and we're told that we have congruent angles here, A and D. All right, so we really want to say by side angle side that these sides are proportional to each other and these angles are congruent to each other. But how do we say that in a proof? So the first thing we're going to do is just use the numbers. We're going to say 12 over 10 is equal to 3 over 2.5. Oh, excuse me, no. We want to compare side lengths of different triangles. So 12 to 3 is the same as 10 to 2.5, and both of those equal 4. That is simply division. All I'm showing is that 12 divided by 3 is equal to 10 over 2.5, and all that equals 4. That is division. Some people might call this simplifying. Either way, I'm just going to keep it the same each time, just call it division. And now I know that AB is 12 and AC is 10. AB is 12, AC is 10, DE is 3, and DF is 2.5. So in place of these numbers, I substituted in those side lengths. This is what I need to show. I need to show that I have proportional sides. That's what I'm showing for side, angle, side. So I have proportional sides. I have the angle that's included in between them. This was the property of substitution. But that completes what I need to show side, angle, side similarity. I need a proportion with the sides, and I need the pair of angles set congruent to each other. All right, on number 4, it's kind of similar, but it's shown differently. It's shown algebraically on a couple of these. So I'm going to say kind of the same thing. Actually, let me just set this up first. 16 this length is marked as 16 and 16, but I'm going to mark that based on how it's given in that first statement. I'm going to label that as 32. This is AC. AE is equal to 2AC. And then BC is labeled as 2x. EQ, or QE, is labeled as 4x. All of those have the same ratio. 16 over 32, the small to big. 2x over 4x, again, small to big. And now I want to do the same thing, small to big. So I'm going to say AC over the entire length here. It is AE, but that doesn't simplify to this same ratio. I'm going to write that over 2AC so that all of these fractions simplify to, or divide, to equal just 1/2. That's a half, that's a half, that's also a half. Even though it's given in side lines, even though this has an x term, all of those simplify to just a half. Now I'm going to substitute. AB is 16. AQ is the 32. 2x is BC. And QE is the 4x. AC, that's fine. I'm going to leave that as AC. The 2AC, I said this actually shouldn't say congruent. It should just say equal. 2AC is equal to AE. So in place of this 2AC, I'm putting in AE. That's what I need. I need to relate all three pairs of my sides to each other and say that that proportion is true. Saying that they all divide to, say, the same ratio, that means that that proportion is true. So I can substitute into that true proportion to show it. And so by side, side, side similarity, we have similar triangles. All right, so it's pretty much the same thing each time. You set up the proportions with the given numbers or given expression sometimes, and then substitute in place of those to show that we actually do have those proportional sides. All right, hope this helps. If not, ask for some clarification.